Hello, recently I was asked to put together an Internet of Things type device for a demonstration for the Internet of Things Calgary Meetup Group. And so I was kind of thinking what would be something that some people might be somewhat familiar with or might sort of have in their house. And I thought I would build a weather station that contained a base unit, and then this would be a remote device that would be outside. Um, So I thought that I could put this together pretty quickly, and then it would allow me to highlight some of the features within Microsoft's Gadgeteer capabilities. So we wanted to have a touch screen, and so we have this one here that displays the data. We can touch the screen, and the data appears and unappears. We're getting the picture off of that from this camera here, but we also save the pictures from the camera on this SD card down here, so we can do like time-lapse photography. We're using a radio frequency. If you've ever used Zigbee, there's these things here that are called RF pipe, and RF pipe is a real pleasure to work with. Like I said, if you've ever worked with Zigbee and having to configure everything like that, RF pipe is basically I have data here, I want to send it here, done. It's really simple to use, and there's by default no configuration really needed. So as I said, this is it's an Internet of Things device. We're using a Wi-Fi signal to send the data up, and we use ThingSpeak, which is a really cool site in order to put our data up onto, so we can see the differences between some of our temperatures and stuff. But ThingSpeak does more than just charts and such. We can use ThingSpeak to send out Twitter messages, or send commands back through Twitter and such. And so I've got things like this with I've set up something where if the temperature drops below 15 degrees Celsius, it sends out a Twitter message to plug the car in and stuff. And so ThingSpeak really has a lot of really nice features that kind of go beyond just showing your data. Has some great ways to be able to interact and with your data and your devices. As I mentioned, it has an internal web server, the main unit, so that you can log in, see the latest picture that's being displayed, and weather conditions and stuff like that. The other thing I wanted to do too with this was I wanted to do a bit of a power study with the unit, because since this guy's going to be outside, it means he's probably going to be running on a battery or solar power type configuration. And so how do you minimize some of your power? Now granted, this isn't really set up for real world situations. I mean, it's taking an awful lot of measurements. It has, as I mentioned, these air quality sensors on them. They're a little bit expensive in terms of power usage, because they actually heat up a coil in order to get a reading and such. So looking at some of the different power management techniques, I was able to get down, like say 25% in my power consumption, which is really good, because when it comes to battery devices, power is king, and such. So what I'll do now is I'll post links to the source code for this, links to the libraries that I'm using, links to Ingenuity Micro, or the guys that where you can get this RF pipe module from. I'll post links for everything here, so that if you wanted to, you could build this if you had Gadgeteer. Now let me say a little bit about Gadgeteer. I'm a software guy. I love Gadgeteer because basically Gadgeteer takes the hard out of hardware. And because I mean, it would take me forever to breadboard different pieces together, but with Gadgeteer, it's much like working like Lego. You can figure out what you need, and it's ready to roll. Now, like I said, as a software guy, Gadgeteer is great, but as a hardware guy, there's also some really good benefits to the Gadgeteer ecosystem. Like I said, this RF pipe module that I love so much. is actually made by a company in England. It's one fellow. He's making these, in his home, and he's able to sell them. And I bought a couple off them. I'm certainly going to be buying some more. They're fabulous, and so like I said, it gives hardware guys an environment that they can build their modules with and sell them. I have hundreds of modules. GHI Electronics is the sort of the main guys selling Gadgeteer. They make the most modules. They're out of Detroit. But I've bought modules from third-party guys all around the world, and really like the Gadgeteer environment. So let's go take a look at some of the code and building Gadgeteer applications. Now, one of the nice things about that, and again, that I really like about Gadgeteer is that I'm a designer. I invent things and stuff, and so one of the problems I have anymore with a lot of tools is that they're very slow. Software development and stuff isn't as fun as it used to be because there's all these frameworks and everything, and levels of abstraction and stuff have gotten to the point where it's really hard to kind of solve problems, because now there's the problem you're trying to solve, and then there's all this other stuff that's around the problem that you have to deal with. Gadgeteer is I love working in Gadgeteer because it's probably the only tool I've seen that can keep up with my imagination. So you have this designer here, and so if I'm thinking of building a device, and so I pick a main board and I want it to do this, that, and everything else. I come into my toolbox and I have all these modules here, and literally I can go, well, gee, I think that we'd like to add an ultraviolet a UV sensor in here, so I can literally just drag it on. If I click on it, it'll show me where I can plug it in, or if I'm just piling a bunch of modules onto the board, I can say right mouse click and then say connect all modules, and it wires it all up for me. So it allows me, as I'm thinking about what I'm wanting to build and I'm throwing pieces out there, it's moving at the speed at which I'm thinking, and which is really great. And then if I want, we can just delete this. And so, from a designer point of view, I mean, Gadgeteer is fabulous. I don't, Arduino or anything like that, they don't have anything like this. And so this is really cool to be able to just design stuff at this speed. And then the other thing is when you get into the code, again, since this is a device that we're working on and we don't have buckets of memory to waste and stuff, the code is very clear, very clean. There's no frameworks or stuff to trip you up where you're not trying to solve a problem, you're trying to figure out how to use a framework and configuring it. Gadgeteer is very clean, and you can use C# like I use, or you can use Visual Basic, where you are using Visual Studio 2012 right here. And the thing with building devices is that devices tend to be very event driven. You don't want to waste CPU cycles or power just kind of idling along and doing pointless things. You want to be able to work on things where something happens, I want to do something. All right, you're in a very reactive mode when you build devices. So for example, right, like here we have when we tell the camera to take a picture, we want to issue that command. But then it would be great if the camera would say, oh yeah, I've got the picture, right? So it raises an event back that says, yeah, oh yeah, I've got the picture. Now what do you want to do with it? And that's literally what's happened here, is that this is, the camera raises an event, and here's the code that we attach to that. So, like I said, Gadgeteer code is very clean code. And so if you have a child that wants to learn how to program, or you have students that want to learn about computers and hardware and stuff, Gadgeteer is a fabulous way to do that because it is so clean, and it's really easy to use. Now, for an example of just how easy this is, so building a touchscreen can be a very daunting task. But if you use Gadgeteer, there's a thing that's called Glide, and Glide makes it really simple to do. And so, if we go down here, we'll look at Glide. So if I want to set up a screen using Glide, I go to this website that's run by GHI, and Glide is open source. And you literally just design the screen that you want. So you put a button here, and text box, and put it over here, and a slider if you want to, and you can move this stuff wherever you want. A text block and stuff. And so, one thing to note when you work with Glide is that you want to give these names that you're going to remember, because you're going to use this name to actually associate an event with, say, a click on the button or whatever. But when you have your screen laid out the way you want, you go in, and what we really want here is this XML file. And this XML file is, like I said, it's how the screen's laid out. And you take this, and where I put it is I put it into my string resources, and you literally paste that in there so that you've got it. As you can see from my XML here for my Glide screen, most of it is text blocks, so they're labels, and that's it. And then, so when you come into the code and we load that resource string into Glide Loader, it produces this window, right? And then we initialize the Glide Touch, and it draws the screen on the touch screen. So this is really simple. Now what we wanted to do was to set up an event so that when someone touches the event, and so the main window, there is a event for touching it called tap event, and there's tap events for buttons and stuff like that. We can assign some code to what happens when you do a touch. And so if we go down here, so all I'm doing with the tap event on the main screen is I'm toggling a flag to say display data or not display data, and then I call this routine here display data, screen data, which basically draws the data onto the screen or not, or clears it, right? So as I mentioned, here's this thing where we do a get child by name. This is why I mentioned that knowing the name is important, because you're going to use that. And that basically gets us the block text, or the block device, that we can then use the properties, set the strings or clear it off. And so we basically just go populate all our text blocks, and then we say invalidate the window, and it redraws everything with our stuff on it. In some ways, this is very sort of early windowish land, where stuff was, building GUIs and windows was really simple. So it makes it really, really nice and easy to build touchscreens. Like I said, we've got SD cards, and everything's event driven, so temperature, humidity. We have an LCD, so when you turn the device on, the LED is blue, and then at some period of time, once we get data from the remote device, it goes to green. But if we don't get data over some period of time, well, it goes to red to alert you that maybe you're something wrong with your outside module and need to go check it. We talked about the camera. Wi-Fi, like I said, this is using a Wi-Fi. I'm using a DHCP connection, so it asks my router for an IP address. We're scanning for an SSID. Nice thing about doing presentations in Visual Studio is that you can say put a region of your confidential settings. You don't want to display your passwords and stuff, and you can basically just hide them all. So all that information's in there. And then it joins up with the Connect and the network. I have a time server on here. I thought that'd be kind of fun, some extra bonus points for code to have a time server on here, so it can handle daylight savings time, because I do display the time on the screen. Want that to be aware of daylight savings. And then the RF pipe, as I mentioned before, RF pipe is it's a real pleasure to work with RF pipe, because it's so simple. So basically, I set up an event handler, so if it receives data, it raises this event, and it's handled by my data receive, which we come down here. And so what happens when the RF pipe receives data? It's just literally, it's just a string. of data, and then we can parse it, and so basically I'm able to get my external data really simply. Now, Gadgeteer uses the .NET micro framework, but micro's kind of a misleading statement, because basically everything that you do in .NET when you're coding is actually in the micro framework. So it's more sort of a testimony of sort of not how small the micro framework is, but by how large the full .NET framework is. So like I said, I mean, to be able to do a string split and stuff like that, that's all in the micro framework. You rarely run into situations where you go, oh, I wish I had something more in the micro framework. But this is how easy RFpipe is to use. It's absolutely a pleasure to deal with. Now, inside this device, we have to have a couple timers. One timer, of course, is a remote heartbeat, where if I don't receive data in X amount of time, we'll just go to the declaration of this. If I don't receive data in X amount of time from the remote unit, we set the LED to red, and we put a message on the touch screen that says check the remote sensor, and then we send an email with have the base unit send out an email to me, and so that's one timer we've got, so that we're always checking to make sure our remote device is up. Otherwise, there's two timers, and the reason we had to have two timers is because we've got these gas sensors, and these gas sensors work by heating up a coil and then measuring the resistance through them. So we don't want to leave the coil on all the time. That's kind of a waste of power. But so what we do is we go 90 seconds with the sensor, the heater coil is off, and then when we want to go get a reading, we fire up a timer we turn on the heater, then we go 30 seconds, and then we grab a reading off it, and then we turn the heater coil off again. So that's why we have two timers here that are running. So one timer is sort of like the master timer. The other timer is to go get the data off the air quality. So we'll hop down here a little bit. That's our. Now I should talk a little bit too about the web server and how easy it is to set up a web server within Gadgeteer on a device. So this is an event that gets raised when we connect the Wi-Fi up. It'll go from its default state of sort of 0.0.0.0 IP address, like not having an IP address, to getting an IP address. And so when it gets that IP address, we want to start up a web server on the main board. So we tell it, well, here's your IP address, and we're going to respond to data on port 80, and we're going to set up events for two types of requests. We're going to set up one event that's just will be the default event. Anything that you don't have, I don't have to say the IP address and then index.html or whatever. I can just type in the IP address, hit it, and this will fire off this event. And so when that request comes in, we're going to call this routine. But we also want to have an event when somebody calls for the IP address / picture.jpg to go get the picture, right? And then this here is just so we have on the touch screen, we have an IP address for where our web server is. Like I said, it's DHCP, so you might be guessing where your web server is. So when that first request comes in, all we're really doing is we're constructing an HTML response with our page, and it's got the data for the temperatures and such embedded into it. And then down here at the bottom, we have this guy here that says, yeah, okay, show me the picture, which then calls this, which check, we see if the picture's null. If it's not null, then we send a picture of the image, and of course it's an image type, or we don't have an image, and so that way we get a nice, we get this this web page out of that. So that works out. I mean, that's really easy to do again with Gadgeteer to be able to set up a web page. Of course, since you can set up different web sort of event handlers for different things, you can make these very complex and very elaborate. I guess then about really we'll go and we'll just look at these timers here, how they work. And like I said, we have one timer that basically just goes around and says, oh yeah, 90 seconds, we're not going to do anything. And then, you know, when that 90 seconds expires, right, we get a tick event. And so what happens here is we stop that timer. We turn on the heating element for the gas sensor. If the camera is ready, we take a picture. And I just so I know when the pictures are being taken, I put the debug LED on the main board. I turn it on. Then the camera takes a picture, and remember, so it just tells the camera take a picture and keeps going, and it starts the sample gas timer. Okay, and so like I said, it just tells the camera to take a picture, and when the picture is captured, it raises this event, and so then we just basically we take this picture and we save it to the SD card, and we put it back sort of like to the default picture that's shown on the web page and on the background for the touch display, which is this all we do right here, right? We just say the window back image is the picture, and we convert it to a bitmap, hit invalidate, and then our picture, our latest picture, sorry, appears on our touch screen. And then, like I said, we save the pictures with a year, month, hour, minute file name, so that they're all nicely organized, and we can do a time-lapse photography or whatever we want. The sample gas timer, so it goes for 30 seconds, and when it's completed, well, we stop that timer. We grab a reading off the gas sensor, and then we turn that sensor off. And we grab sort of the last reading time just so we have a reference point. And then we start setting up the data that we're going to send up to ThingSpeak. So with ThingSpeak, we come in here and we're just populating this data structure. Now we may or may not have data from the external module. If we do, that's great. If we don't, well, okay, so we're going to clear that off. We don't want to send that data up. We don't want it to appear in the chart because we don't have it. But we want ThingSpeak to send a Twitter message for us. So there's some fields inside these inside of this ThingSpeak library that allows us to do that. And then we just send this data structure up to ThingSpeak. Now this is a third-party library that I'm using. I'll include a link for that down below. And like I said, it makes working with ThingSpeak really easy. So then we get our data coming up to ThingSpeak, which is great. But we also get, like I said, we can get Twitter messages. So I have a user ID for playing with my devices. I call it my Gadgeteer, and so you can see that it's sent out various messages and to check the external module and stuff. Now, as I mentioned, ThingSpeak has some really nice features for working with Twitter messages, and they're great. I mean, to set up a ThingSpeak site, you create you register for ThingSpeak, and then you go in and you create a channel. And so I've created a number of channels for different experiments that I've done over a while. And so this is my ThingSpeak channel for this. So you have these different channel settings that you can have, descriptions, and then there's 8 fields of data that you can send up, which makes it really great. It's really easy to use. And then, as I mentioned, there's these different apps that you can use to do ThingSpeak with. For example, that one plug in the car, make up below 50 or and such. Now, when you ask ThingSpeak to send a Twitter message on behalf, of course, it's going to do an authentication, and that's really easy to do with ThingSpeak. Like I said, you give it your account, give it authentication permissions, and you're off to the races. So we'll go back to this. And so basically, that's it, other than, I set up this internal time server with my daylight savings and stuff so that I can get this. And as I mentioned, it's really simple to code with Gadgeteer. Something happens, what do I want to do? And like, for example, when we ask for a temperature or humidity reading, the reading's complete, we get this event, and so what do you want to do with it? Well, I just want to save these values to here. And so, that's it. This is 500 lines of code, counting white spaces and stuff, and so it's really easy to build. Now, we'll take a look at what this looks like from the remote. We won't save this. This is there because we did that little demo of adding a module. So again, when we come in to look at the remote, it's the same sort of thing. We just drag stuff onto our designer, tell it to hook it up for us, and we're off to the races. And again, we have the same sort of thing. We had the option of 2 different timers to do that heating cycle for the sensor. I was looking at experimenting with different ways of power management with this. So like I said, with Gadgeteer, it's real easy to do, but you can do some of the advanced features as well. And so, like one of the things I was looking at was doing a power hibernation and such, and this is actually the best way to do this. You don't want to do this when you're in debug mode, because when it goes into hibernation mode, it hibernates, so it breaks actually your debug connection. As I mentioned, using the that RF pipe is really easy to use. That's all you do to send data with RF pipe. You build yourself a string and you send it. Absolutely trivial. Like, the remote unit isn't going to receive information back from the base unit. It just sends information out, so we don't have to deal with any kind of events coming back. We just want to send data out, and RF pipe makes it really, really simple to do. And then, like I said, that's it. There's hardly any code again for the base unit. So we'll just go back. I should show, we'll close the solution and we'll just go back, and I should show a little bit about how, that's not what we want, sorry. Wrong file. When you work with Gadgeteer inside of Visual Studio, you get the full power of Visual Studio, so you get full debugging and such, and it does everything for you. And you can look at variables and stuff. So we're going to set a breakpoint just as kind of an example. So when you write your code in Gadgeteer, you write it all. Hit the start button. It compiles your code for you, grabs all the libraries and stuff that it needs, loads them onto your device for you. So it makes writing stuff really simple, because it's just like writing any other program, because Visual Studio handles everything for you. So there, it's deployed everything, and it's firing this all up for me, and we've hit our breakpoint, right? And we can go in and we can look at all the properties of stuff. We can change colors, we can change values, we can set next step and stuff like that. So with Gadgeteer, you've got, if you use Visual Studio to write anything else, you can use Visual Studio to build devices. It's really simple to do, and so we'll just let that run. I'll set a breakpoint there. We may or may not hit that even by the time I'm finished this, but if we do, we'll just kind of walk through it. So like I said, Gadgeteer it's a great tool for kids wanting to learn about programming and stuff. So our remote device sent us some data. We can. Now that was funny. I went to hit F10 to do a step over, but of course F10 is the default key for stopping a Camtasia recording. So that's kind of funny. Well, I won't do that again. So we'll come up here and we'll just say, we'll set a breakpoint here. We'll say continue. And then, like I said, we can go back and we can look at all the values and stuff that we received. you know, what the string was that we received and stuff. So I mean, it's full debugging with Gadgeteer, which is again a fabulous feature of device development with Gadgeteer, and that the tools help you to get things done quickly and properly. It's like I said, it's a real pleasure to work with. And so we'll just let that run on. And oh, while I've been sitting here, it's already queued up another event. And so we've got some events that we're waiting to be processed. So we're good. So like I said, Gadgeteer is a fabulous tool that everybody really should give a go, considering that they're predicting billions of Internet of Things devices coming over the next X years, and that it's a hot area of software development and IT in general. Gadgeteer is a great way to do it because it's a tool that's fully supports the development thereof of such devices. Again, I will post links, source code, everything for this. So if you're interested, you're more than welcome to look at it and experiment with it and such. There'll be a discussion thread on GHI Electronics forums for it, and if you're interested in any questions or anything, I'd be happy to try and help you. My name on that forum is Duke Nukem. And so I do hope that you get a chance to try Gadgeteer at some point in time, and I trust that you'll enjoy working with it and playing with it like I have. I've built everything like weather stations, the robots, the medical devices, to games, to all sorts of stuff with Gadgeteer. There's piles of different modules and more modules coming all the time. For this, there's all sorts of different main boards, so you can select your main board based on what kind of CPU power and such that you want, what kind of features you want. There, some of these main boards use industry standard type boards, so that going from a prototype that you've built to a finished product that you're deploying in the field and such is very possible with Gadgeteer. Again, I'd like to thank you for watching this and my other videos, and I'm kind of in a rush to get this module apart because I'm using both my temperature humidity modules in here, and now I'm anxious to go and build a snowpack monitor because I'm interested in the melting rates of all the snow that we have around here in Calgary, and so I'm anxious to get that other device put together this afternoon and out in the backyard. And again, thank you very much. Bye.